Hello everyone. So do developers dream of stateless apps? So some time ago, I get back to lecture of book by Philip K. Dick, Do Androids Dream of Electric Sheep? And you may know this story also from the movie with Harrison Ford and Rutger Hauer, the movie Blade Runner. And in the sci-fi world, so-called Blade Runners are kind of detectives that are trying to investigate and retire problematic androids. And I thought that our job is quite similar because we are trying to investigate and solve problems. And in Blade Runner, the problem was that, of course, androids wanted to live their lives. So they strike back and make the detectives' lives very difficult and dangerous. And in our case, it's quite similar because our lives are also infected by one bad guy. He's called state. And state can really tackles the availability of our systems. So today I would like to discuss how to deal with him. And there is the question, do we dream of stateless apps? My name is Lukasz Gebel, and I'm a software engineer at TomTom in Location and Navigation Services department. There I build services like matrix routing that helps people to optimize fleet of cars, for example taxis, to get on time, safe and sound. What's more, we work also on batch systems that process a high number of requests and provide a combined responses. And our systems have to deal with state, and they are running in Azure Cloud. And that's why today I would like to share my experience with you. So I will start with short introduction about state definition and how we can distinguish stateful and stateless architectures. And then I will go to three main chapters of my presentation. The strategies that helps us to increase the availability of our systems, the tools that helps us to handle state, and I will focus on their HA features and my experience with using that. And in the last chapter, I will demystify the acronym SLA and we'll do some math. So let's start with defining state. So probably intuitively, all of us, we know what state means. However, it's quite primitive and natural idea, and it's quite hard to define it. So according to Cambridge Dictionary, state is a condition or a way of being that exists at a particular time. So like a state of a light switch, it can be on or off at a particular time. Also, people are in some kind of states. We may be happy, interested, and so on. And all of natural ideas are usually moved to the computer science world. So how can we understand state in the computer science world? According to definition, a program is described as stateful if it is designed to remember preceding events or user interactions. So the remembering, the brain part of a program is crucial part in this understanding. And the remember information is called state of the system. But according to this simple definition, probably all of our programs could be understood as stateful because state is really everywhere. So we keep state in variables, in databases, in files, so it's everywhere. So let's discuss three most typical architectures. The first one, the fully stateless model. So here we've got copies of the same servers that handles requests with the same app, and we've got two clients which sends our requests. And in this fully stateless model, every server is capable of handling every request of each client. So it's a very simple model, and it's very flexible because we can add and remove our servers on the go. The second model, which is quite controversial as I read on the internet, is stateful or stateless. So here we also got this number of the same servers that handles requests. However, they have to communicate with the third-party component that keeps state, for example, database or some kind of cache, storage, and so on. And I was surprised because there are some opinions that this architecture is also stateless, because according to these opinions, servers can handle requests from different clients. They are not assigned to the one client all the time. And they have all the information they need in a third-party component. So some of us thinks that is a stateless architecture. However, this DB part is quite crucial in this architecture, and it cannot work without it. So in my opinion, it's flexible but stateful system. And the third model, fully stateful, here we've got something called sticky load balancer, and it makes our request from one client goes all the time to the same machine. So server one can, for example, handles client 2 requests all the time, and servers itself have all the state that is needed to handle the given client requests. However, it's very poor architecture, and I would call it rather an awfully stateful architecture because it's not flexible at all. Let's imagine that your server crashed or it's overloaded and you are doomed. So unless you are sure you need this kind of architecture, don't go that way. Okay, so let's start the first chapter, the high availability strategies. So the most common strategy is simply scaling. So we can scale up if we have one of this flexible architecture and provide more copies of our servers. So the probability that all servers will go down is lower than if we had a one server or two servers. And this approach is called horizontal scaling. Vertical scaling may help us to deal with higher load. However, it sometimes requires stopping our machines or stopping our applications or adding more resources to this machine. So it's getting bigger and more powerful. So probably in most of our architecture workloads, the horizontal approach is most common. And the second basic strategy that we can go for increasing the availability of our system is multi-region deployment. So in our cloud environments, we've got geographical regions, which stands for data centers. And in these regions, we also can have smaller units called availability zones. And each of the availability zone is a data center or a set of data centers that are quite independent from each other. So they increase the availability of our systems. So let's look how it is done in Azure and AWS. So according to Azure documentation, they have 58 regions. However, if you scroll down, it turns out that they have 52. So you have to be always careful while reading the docs, and 6 regions are yet to come. So 10 regions support availability zones, and each of these regions have at least 3 availability zones available. AWS have different approach. So they have only 23 regions. However, they have 70 availability zones. So they are recommending to optimize your flows for availability zones. And 2 or more AZs are available in all of the regions except the new one, the small one, Osaka, which is recommended to go with pair with other small region. So when you plan your infrastructure, when you plan how your resources will be spread through cloud infrastructure, you can go like for scale sets, availability sets, and so on. And there is this idea of fault and update domains. They are called so in Azure, but the same concepts are similar in other cloud providers. So fault domain is like, for example, a rack servers. So if you have a couple of machines, you could put them on different racks, and this fault domains makes it more available because they are, for example, may have different power supply. So if one rack goes down, the other racks are still up and your system works. And update domains works the same way. However, they are used when cloud provider needs to do some maintenance, update your software or hardware, and then you're sure that not all of your racks will go down, but it will be done sequentially using these update domains. So When you spread your machines, you can go for availability sets, scale sets, and then your machines are close to each other. And if your workflow, your data flow requires communication between the machines, so these machines communicate a lot and send a lot of data, you gain, of course, the latency, because the latency will be lower in such case, because machines are as close as possible to each other. However, you lose the availability, because if one region or one scale set is down, then your system may go down. So if you'd like to go for availability, you can spread your deployment through availability zones or through different regions. However, if machines between regions needs to communicate a lot, of course, the latency will be higher. So there are always trade-offs, and you need to get the right idea for your needs. And in AWS, we've got this placement group, and you can choose from cluster placement group, which means that all of your VMs will run on the same rack, the partition. So you can define logical partition and choose which machines goes for which partitions, and the spread one, which will try to spread all of your machines equally through different fault domains, different racks. But why we should even care how our infrastructure works under the hood? So some distributed systems, and very often stateful systems, need some kind of coordination. So for example, we can have a cluster that needs to distribute the configuration or synchronize some state. And we could use, for example, Zookeeper, a well-known tool for cluster synchronization. And Zookeeper works this way that it needs to have a quorum, so a quorum of machine of instances, and the minimal highly available setup of Zookeepers is 3 instances. And in this setup, one Zookeeper may go down and cluster still goes, but if 2 Zookeepers are down, Zookeeper doesn't work. So let's say that you didn't care a lot, you get your highly available setup and go with region that have only 2 fault domains. So your Zookeepers will be set the first rack, you will have 2 Zookeepers. In the second rack, you will have 1 Zookeeper. And then in case of natural disaster, for example, a big storm, let's say that you're unfortunate and the rack with 2 Zookeepers is down. It means that you still have 1 Zookeeper, but it's useless because he cannot cooperate with at least 1 more Zookeeper. So your highly available setup is not really highly available. So you may say, okay, so let's scale it up and let's go for the next number in Zookeeper setup, which is 5 machines. In this setup, 2 Zookeepers can go down. However, the situation will be exactly the same. Your machines will be spread through 2 fault domains. When you are unfortunate, your 3 Zookeepers are down, and these 2 guys will simply be useless. So you also always needs to be aware of what's happening under the cloud and be careful when you are choosing region if it has given number of fault domains or update domains. Okay, the second chapter, the highly available cloud services. One of the most common service that is widely used while dealing with state is always database. So when we were migrating to Azure and we had to choose our database, there was not much to choose from. And there was Azure SQL. And Azure SQL is simply a DB as a managed service. And under the hood, it has the Microsoft SQL Server database engine. And it had really cool scalability and highly available features. So I will try to discuss them. Regarding scalability, it was advertised as dynamic scaling. However, you need to be aware that dynamic scaling is not the same as auto scaling. So you simply get the switch and you can manually scale up or scale down your database. It won't be done automatically. If you'd like to go with more automatical approach, you can go for elastic pool. So you can assign and shared resources to a couple of your databases, and then these resources can be used by those databases if needed. Or you can implement your custom metrics, and if you see that you need bigger database, you can use the Azure API and scale it up with your custom implemented solution. But what's about different HA features? So we were interested in two of them, the active geo-replication and failover groups. So active geo-replication simply gives you a primary database in a region of your choice and a secondary database in the same region or in a different one. Then you get also asynchronous data replication and something called failover, but it's a manual failover to secondary database. So it means that you can simply push the switch and primary becomes secondary. However, probably all of us don't like manual solution, because if your database is down, you simply need to get your on-call phone, wake up at night, your dreams are disturbed and you are nervous and your customers are nervous. So we need a different solution. So we went for failover groups. And failover groups, you've got similar setup, but then your secondary database needs to be in different region. And you get really cool feature called automatic failover. So it's like a robot which switches the primary to secondary in case of failure. And you get one connection string, which points always to the current primary database server. So it seems cool. And Azure recommends to deploy your database in paired region. So for paired region, for example, West Europe and North Europe, you get this promise that physical isolation will be done and the region recovery order. So if two of your paired regions will be down, one of the regions from the pair will be prioritized to recover. And you get the sequential updates. So never two regions from the same pair will be updated at the same time by Azure. Okay, so let's look in practice, how does it work? So I prepared a simple Android factory application, and our Android model has identifier, first name, last name, and a version. Very simple model. And regarding data access object, I have this Android SQL data access object, and it's simply JDBC based data access object. So I've got a select all Androids, and I have insert Androids into Android's data table. And the code itself, and the code, the app itself. So app Azure SQL, and it's simple executor service that runs every 200 milliseconds and creates new Androids and then gets all of the available Androids and log its size. So I will run it now. It's a Spring Boot app, and we should see the number of available Androids in our Android factory. Yeah, so it's incrementing. Now I will switch to my Azure portal account and Azure SQL powered factory. So that's my setup of databases. So I have two databases in East US and West US, and two servers in East US, West US for each database. So let's check how does failover group feature look like. So we've got this map that depicts which regions are paired and replicated. And we also have the primary and a secondary database, and our read-write endpoint, single connection string, and read-only connection string if you'd like to diverse your workflow. And I can simulate a failover. So I will go for the brutal failover, the force failover. So yeah, I have to agree that it may not work. So let's check how our app is working. Will it be stopped or something? Oh, yeah. So we get some errors, but it seems it's working. So we've got the connection reset errors for a couple of seconds. However, our application is up and back to normal. It still works. So the failover feature works really cool in this example. But what was my experience and the experience of my team? So apparently we were very sleepy when we were using Azure SQL, because many times at night we get alerts due to database outage. And this failover feature, it didn't work that way in the past. So when we tested it, each such of failovers lasted from 5 to 10 minutes of the database outage. So it wasn't really cool. And very often database, for example, your primary database wasn't available, but any failover didn't happen. So it was like replicas inside one region were failing, and it could cost you like 2-3 minutes of an outage. So we were really unhappy and depressed due to this Azure SQL features, because it was like bad promise from the cloud provider side. But there is a hope, as you could see in the demo. For now, it looks really cool. When I tested this feature in October, it still didn't work, but now it looks cool. And they added also a business critical tier, a zone redundant deployment. So I think they improved it a lot. And it's not like anymore that they couldn't help us in the short term and it worked as it was implemented simply. So I'm really happy with the improvements here. But we didn't have choice. Oh, sorry. And if you're interested in the equivalent service in AWS, you can go for Amazon RDS. However, nevertheless, we were very unhappy. So we had to resign from using Azure SQL. So what could we do? So we lay down, cry, and look in the sky, and that's how we discovered a Cosmos DB. So Cosmos DB is a multimodal DB with API of SQL, MongoDB, Cassandra, Gremlin, if you like, graph-based databases, and it's simply a document-based database. But it has really cool HA features. So Cosmos is available through all of the Azure regions. It has single master mode, multi-master mode, and you can remove and add regions on the go as you are using your service, which is really flexible. It has this multi-homing API, which means that your clients will interact with the replicas that are closest to them. And it also has these regional failovers features. Regarding replications behind the scene, so you get at least 4 replicas of your data partitions in every region you use, and every partition may land from 10 to 20 different fault domains. So it should be really highly available. So I will do the same demo as I did with Azure SQL now. So maybe the code at first. So Android model will be the same. However, I will show you the method that is needed. So I simply needed to add serializing to JSON. And let's look at the data accessed object for Cosmos DB. So I use the SQL API. So I simply have this select all Androids. And when I want to create an Android, I need to use a document abstraction and put a JSON of my Android and just put it into my collection. So when I go to my app, it looks pretty the same way. Executor service, adding new Android, and finding all Androids and running the app. So now I will run it, and Androids should be added to my document collections. Yeah, so it's adding. So let's switch to the portal. And here I have my Cosmos DB account. And inside the account, I have Replicate Data Globally tab. And here I also have map, and I can see which regions are used currently, and which region is a write region, it's West Europe, and North Europe is a read region. So let's do the manual failover. I didn't go for multi-region writes because I wanted to have set up as similar as possible to the Azure SQL, so we could compare it. And now I will go for failover. and it's in progress. However, our Androids are still adding. We don't have any errors, and I bet we don't get any errors at all, even if we are waiting for hours. So we did a lot of experiments. However, we have never experienced any problems with Azure, with Cosmos DB during failovers. So it's really cool tool. And in comparison with Azure SQL and our experiences with Azure SQL is much better. We really didn't get any of the outages due to the Cosmos DB itself. However, as every tool, it has its limitations. So for example, document size can be at maximum 2 megabytes. You have only 5 geospatial functions if you need such things. For example, if you are using PostGIS, and you have to remember that it's a document-based DB, so probably it won't fit you in all of your use cases and scenarios. In Amazon, you can use DynamoDB. I haven't used it, but that's probably the equivalent of Azure Cosmos. You can play with it by your side. Okay, storage. So sometimes we need to keep backups, logs, shared resources in storage. And in Azure, we've got Azure storage accounts, and we can check different options for replication of these Azure accounts. So the simplest one is locally redundant storage, and it means that you will get only 3 copies within one data center that you choose, one region. If you need to increase the availability of your data in case of failure, you can go for geo-redundant storage. So we get 3 copies in your primary region and then in the secondary region, but there is a trick. So you cannot read this data in the secondary region. It will be available in case of failure of your primary region, but it's not available for you as you go. If you want to read it, you have to pay for it, of course, and you have this read access geo-redundant storage. And now you have 2 copies, full writes and full reads on both primary secondary regions. If you need to go deeper, you can go for Azure Storage V2, and it supports zone redundant storage. So your data will be replicated through different AZs. If you need even more, you can go for geo-zone redundant storage. So you get the availability zones in secondary region. However, still you won't be able to read your data in this secondary region. So you can finally end up with read access geo-zone redundant storage, which is really cool. But of course, be aware that you need to be aware of what we are asking for. So if you are asking for redundancy, you will get it, but this data won't be there immediately when you push it to the primary region. If you need to have fast storage, probably locally redundant storage is all you need. So always be aware what you're looking for and of its trade-off. Okay, in Azure Storage Package, we also have this Azure Queue, which is really useful when you need to integrate different parts of your services or different services. And the messages on the queues have infinite time to live. And all of the messages can have up to 500 terabytes. And the order of the messages is not guaranteed. If you need the order, you can go for service bus message session. And my favorite sentence from Azure Queue documentation is that unlimited number of concurrent clients is supported. However, it's not so difficult to use even 1 or 2 clients that put a lot of messages per second and get the 503 server busy. So it's like a fun fact about the Queue client, but you will probably see a lot of these errors if you won't choose your queue or the queue won't be scaled up enough under the hood. And I would really advise these guys to not put such sentences in docs, because it's very dangerous. It's really easy to break it. Okay, in AWS, you've got S3 for storage, and SQS. And my experience is that they had already in the past very mature Java SDKs. And in comparison to Azure, at first the Java SDKs were not very cool, but they improved a lot. And I really mean it. So you can create a pull request, report a bug, and guys from Microsoft on GitHub, they are working and they are very responsive. So they did a lot of work through all of these years to improve the Java SDKs. So they are not only focusing on .NET ecosystem, which is natural for Microsoft. So that's one of the experience. And the different story is that you should be always ready for the failure of your hardware if you're using storage, because it will happen sooner or later. So you should be able to take care of your storage lifecycle, because as I said, it can break, but when new storage versions are applied, they, for example, are applied on new hardware that you can benefit from. But if you are still using the old ones, they may not be migrated to the new ones and you won't benefit from the new features. So be ready for migration. How you can do it? So you can go for the proxy approach. So you've got two systems, your version of your systems. You can put a proxy before it and distinguish old requests that should be handled by the old version of your system and the new request to the new version. However, probably you will maintain this proxy only while you need this migration, and then you will forget about it. So this component will get rusty and won't be ready when you will need it next time. So maybe it's better to go for a dynamic approach. So let's say that you've got a pool of storage accounts, and if the one storage account is unhealthy, you make your system ready to get the storage out of the pool and add more storage accounts if you need, or just to get newest storage accounts if you want to switch to the new ones. So dynamic approach is much better than the proxy approach that I presented before. Okay, so the third chapter, the service level agreement. So service level agreement is simply a contract between a service provider and a customer. So probably we are on both sides. So we are buying services from cloud providers and we are selling our services to our customers. And it stipulates some minimum quality of service. And if it's violated, we get money or we have to pay money depending on which end we stand. So how we can understand the SLA? I like to use this SLA calculator because it's made with the secret alien technology Lisp, and it really fits my background story about Blade Runner. So now I will show you this calculator. It's available online. And you can put a number because SLA is expressed in numbers, in percents usually. And for what does it mean? So 3 nines means that your system can be unavailable for almost 9 hours a year, which is a lot. So if you want to increase your availability, offer a bigger availability, you need to increase the value of SLA. And for 4 nines, for example, you can see that it means that your system can be down only for almost 1 hour, 50 minutes. So that's how we can understand the SLA. So it's like up and down time. So how can we calculate it for our architectures, for our systems? So I will use this example. Let's assume that we've got a DB which has SLA at a level of 4 nines and the storage that is at the same level, 4 nines, and both services needs to work all the times, so the service is up. So let's use the uptime approach for calculating our SLA. We'll use probability, and two events, A and B, are independent. The probability of such independent events is simply the probability of event 1 times probability of event B. And we will use this definition. So our DB is up 4 nines, our storage is up 4 nines. So after multiplying the SLAs in the probability form, of our services, we get 3 nines and 8. So we used only 2 services, but we have already lost 1 9, which is really bad. So, okay, maybe we should go with some strategies that I described, and let's go multi-region. So we deployed our app in different regions, in 2 regions, but we need to have a traffic manager in front of our services. So it simply routes requests to different regions. Okay, so let's say that we've got Europe and US region, and if our system is up, it means that Europe or US is up. So we can put it the other way. So the maximum probability of being up is 1. So we've got 1 minus the probability of Europe and US being down. Because if both regions are down at the same moment, our system is simply down. And how to calculate this one? By multiplying these independent probabilities. And we know that the probability, that SLA of our system that I calculated before for one region is 3 nines and 8. So probability of system being down is 1 minus 3 nines and 8, which gives us this value. So probability of Europe or US being up is 1 minus this complex digital numbers, and we land with like 1, 2, 3, 4, 5, 6, 7 nines. Great, so our SLA increased a lot, really a lot by adding different region. However, we forgot about Traffic Manager in front of our system. And Traffic Manager has its own SLA, and it's 4 nines. So we need to multiply the Traffic Manager SLA for our multi-region deployment SLA. And we then end up with 3 nines again and 8. However, we are very close to regaining our 4th 9 again. So as you could see, it's not really easy to get the level of SLA that you had before, even if you go for multi-region deployments. So complexity of your system is deceptively simple. So it's very easy to add a database, or then you think, okay, so let's get some queue and storage, and maybe we can add some cache and some more services. But every time you add your services, your system is getting more and more complex, and the probability it will break, it's usually bigger. So be aware of it, and sometimes maybe it's better to struggle a little bit with your architecture than going with the simple solutions like adding new service, because it will harm your SLA. Okay, so I discussed basic strategies to increase HA. I described the tools that helps us to deal with state and the HA features. And then in the end, I showed you how to calculate the SLA for your systems and how to understand it. So now I've got call for action for you. So I would like to ask you to calculate your SLA when you get back to your work or at home for your hobby project, and simply check the value if you're happy with it or unhappy with it, and what does it really mean for you. Or maybe it will be just be the informative value that you're aware, okay, my SLA, at least theoretical SLA, because of course that's a theoretical value, is that. So it's like a thought experiment for you. Also, please play with HA features and always be ready for failure, because sometimes, as we, in our case, in Azure SQL case, even though we had this Azure SQL HA features, they didn't really work and didn't really make our system HA. And the third call to action, be aware of how you are using your geo infrastructure in cloud, how your resources are spread through your global infrastructure, so that you not only think that your system is highly available, but it really is. Okay, answering the original question, do we dream of stateless apps? I think we shouldn't, because state tackles the availability. However, it brings a lot of challenges, and challenges are really helpful and help us to develop and makes our work really interesting. So instead of running away from state, I think we should, if we have to use it, we have a lot of challenges that can we learn from and benefit from as engineers. So that's all of my experience. That's all I'd like to share today. I hope it won't disappear like tears in the rain. Thank you very much. And now I'll be happy to answer your questions if there are any on Slido. So here is the bibliography, and the slides will be available under this link. You can also follow me on Twitter. I will put the slides there. And I'm looking at the Slido, but I don't see any questions. So please share your feedback about the presentation, about the topic. Please share your thoughts on Twitter if you like. I'll be really happy to talk with you and to answer all of your questions. And I hope that in the future we'll meet in person. So take care, guys. Stay strong. Thank you very much. If you still have some questions, you can still write it on a Slido.